A type of sequence we're going to study is called the arithmetic sequence, and it's special in the sense that each term in the sequence differs by a specific amount called the common difference. The sequence either increases if the common difference is positive or decreases if the common difference is negative. So we want to sometimes generalize the sequence or give just one formula that could describe a lot of things in the sequence. So we call this the generalized formula or the nth term formula, and this is what it looks like for the arithmetic sequence. Now we can find many different things using this nth term formula, and this is what we're going to do throughout the video. But it's important to understand what each term means and how we can use them in each question. So the first thing to note is that D refers to the common difference, and you can easily find it through taking any two consecutive numbers in the terms in the sequence. So if you have, for example, 2, 4, 6, 8, the easiest example, if I take any two consecutive numbers and I find the difference between them, I could see that I'm always adding 2 every single time, so my common difference is a positive 2. So this becomes a positive 2. If it was the other way around, 8, 6, 4, 2, and so on, so I could tell that I'm decreasing by 2 every time, so my common difference is a negative 2. So you can just substitute a negative 2 here, for example. The other values are N refers to the position in the sequence. So this is very important to note that if you're talking about the 5th position, the 1st position, the 10th position, this is where you put the position value. This is the position you're looking at. And UN refers to the term in the sequence. So if the 3rd position has the number 26, then UN refers to 26. So what's important is to see what these to link this N and this UN. So if my position is the 4th, then U4, for example, again in this very easy sequence, U4 is going to be 8. So the 4th position, in the 4th position, my U4 is 8. So this is important to note. So these two will always link together. So we replace UN with the actual term, and we replace N with the position of whatever you've placed here. And U1 will refer obviously to the 1st term. So in an arithmetic sequence, the two most important information to have is the 1st term and the common difference, but sometimes the other terms are missing. But let's follow through some helpful tips before we solve some questions. So first, write down all the information you have. What do you have? Do you have the terms? Do you have the position? Do you have the common difference? Do you have the 1st term? Maybe some of these are missing. And note the unknowns required in the question. Maybe one of these are missing, maybe 1 or 2 are missing. You need to form an equation, or maybe more than one equation based on what you have. Sometimes you'll end up with simultaneous equations. And then either solve the single equation and then you get the value you need, or you'll end up with simultaneous equations and you get the required unknown, or maybe a set of unknowns actually. So using the formula, a very simple example, if I have 5, 8, 11, and 14, this is a sequence. I can immediately see the beginning. I could use it to find the common difference as well. So I need the general nth term formula. And then I need to use the formula to find the 7th term. You can pause the video and try this on your own. So first I'm going to know what I have. I know that the 1st term U1 is 5, and I know that the common difference is a positive 3. So I substitute this into the formula. I have the U1 and I have the common difference. So once I substitute those in, I'm going to expand out here. Make sure to expand out and then simplify, and then you're going to get this general formula. So then I need the 7th term. So I need U7. So once they say U7, it means this will be replaced by U7. And U7 means that the N, which is the position, remember these two will link, I will have to replace it with a 7. So I multiply out and simplify to get a 23. So how to use this formula can be discussed in more detail in another video, but this is a quite easy one. It's just a matter of substitute in and then simplify the expression to get to the 3n plus 2. You can also just leave the 5 and the 3 here and just leave it as it is, and then when you get to finding u7, just plug in the 7 in there. So you can try that on your own. Now, sometimes other things are missing or we're giving a different piece of information than what was done in the previous slide. So in this example, in these two examples, you can pause the video and try them on your own. I would definitely recommend that. So for the first one, we're given the 21st term. So we know that the 21st term is 65. And we know that the common difference is a -2, so it's decreasing. And we need to find the first term. So first, if I look at the formula, what I have is I have a u21, so I have a value. This will be replaced with 65, so u21, this will be replaced with 65. Remember, this is, you can't just write u21. It would have to be replaced with a value. In some instances, you can keep it as u21. So then this will link with the n here, remember, so since this is the 21st number, 65, so if I write 65, then this will have to be replaced with a 21. And the common difference is a -2. So once you expand that, simplify it, make u1 the subject, you're going to end up with 105. Now it seems a bit odd because it's a big number, a bigger number than 65, which is down in the sequence. Well, remember that this is a decreasing sequence, so it would make sense to start with a big number, keep on decreasing by 2 until we got to 65. So try to make sense of the numbers you get as well. In this example, it's a bit different. You can actually solve this example in a different way, and I think I do it in another video, so you can look at that method as well. So there are many different ways of solving this, where you're given two separate terms, and you are meant to find, as it says here, the 19th term. So you're not given the first term, you're not even given two consecutive terms to even be able to find the common difference. So how can you do it? Well, in order to find the 19th term, you actually need to know the first term and the common difference. So we don't have that, but let's try the information we have. So what we have from these two pieces of information, we have the value, the term value, and we have their position only. But we're missing u1 and the common difference to be able to find the 19th term. So let's find these two first, and then we're going to find the 19th term. So what we're going to do is we're going to write equations in terms of each. So just as we did here, we're just going to do it with u5. So this is -3.7, and it's the fifth position. Remember, these two will match. And we're going to do the same thing with 15. This is -52.3, and the position is 15. Now, what we have here is a simultaneous equation, and you can simplify this. 5 minus 1 is 4, so you're going to end up with 4d. 15 minus 1 is 14, so you're going to end up with 14d. And then use simultaneous equation to solve this. If you need help, there's another video on this. So solving this is going to give you the first term as 15.74 and the common difference as -4.86. There's another way to find the common difference, a quicker matter, but this is a more formal way. Once you have the first term and the common difference, you can use them to substitute in the general formula. And once you do that, you can easily get the 19th term. So you're just going to substitute the 19 here, -1, and then you get -71.74. And this is the only time where you can actually write u19 instead of the actual term. It's when you're trying to find u19, u sub 19. So otherwise, if it's already given to you, like u5 and u15, just substitute it in here. So these are some ways where you can use the arithmetic formula to solve questions. It's important that you're flexible with how to use them and really understand how to use the terms and when to use the term, where to substitute, and so on in order to solve more complex questions.